What's going on YouTube? Coach Carr here, bringing you another video. This one is still on quadrilaterals and it's on page 6 and 7. So I hope you enjoy. Okay, so we are looking at page 6, number 7. It says the size of the acute angle of a rhombus is half the size of its obtuse angle. The side length of the rhombus is equal to 20 feet. Find the lengths of the diagonals of the rhombus. So with this word problem, first thing that I recommend doing is drawing it out. Now I know I have a rhombus, so that's another way of saying that you have basically a diamond. And they told us that the side lengths are all 20 feet. Now in a rhombus, all sides are congruent. So I know all the sides are equal to 20 feet. Another thing to know about rhombuses is that the diagonals that are inside are going to be perpendicular. So they are going to make right angles in each of these. We also know that they bisect the opposite angles. So now we're going to try to figure out what our angles are so we know what each one's going to be. So when they say the size of the acute angle of a rhombus is half the size, the way you would write something's half the size, it would be what you'd have to be doing is multiplying it by 1/2 or 0.5. Now, I put it with x because we don't know the actual number. We just know it's half the size of the obtuse angle. So, half the size of the obtuse angle. Now, that's something that we don't know yet, so I'm going to add that with x. So, if I had the obtuse angle and the acute angle, both of them together is going to have to equal 180. Because just like in the parallelogram, where consecutive angles are going to be supplementary. So I know that these two angles are going to have to add up to 180 degrees. So first thing I want to do is add up these two. So our like terms. So 1/2 x isn't another way to write that is 0.5. So I'll just write that down here. 0.5x plus x equals 180. If I add those together, remember there's that invisible 1 in front of the x, I would now have 1.5x equals 180. Now I want to get x by itself, so the next thing I would want to do is divide by 1.5. And when you do that, 180 divided by 1.5 is 120. So remember that the x was the obtuse angle, 1/2 x was the acute angle. So the obtuse angle, we'll put that here, the full thing here equals 120. So this angle, our obtuse angle, the full thing equals 120. Now, if this is the full thing's 120 and the diagonals bisect it, bisect means it gets cut in half. So this part would be 60, this part would be 60 because it got cut in half. Now, 1/2 of x, where x is 120, the acute angle, the full thing is going to be 60. But if I cut that in half, you then have 30. So the obtuse angle, again, was 120. The acute angle is 60. So that's where, because these got cut in half, that's where I got these. Okay. So if you notice, what we just did was we broke up the rhombus into triangles, basically. And specifically, there are special type of right triangle, which is it's a 30, 60, 90. That's the special triangle we have. Now, if you don't remember, we had formulas for each of the sides in a 30, 60, 90. The short leg, the shortest side, is x. The longer portion is going to be x square root 3, and the hypotenuse will be 2x. So in this case, our hypotenuse would be where the 20 is. So instead of 2x, we would have 2x equals 20. And when you have that, to find out what x is, divide that by 2. So x equals 10. So the short leg is going to be equal to 10. So now that we know that that is 10, that would be like saying that this length here is 10, this length is 10. So if both of those lengths are 10, the full diagonal would be 20. So one of our diagonals is 20. 20 feet to be exact. Now the other diagonal is made up of the longer leg on there. So since we know that the x is 10, if I put into the equation for the long leg of x square root 3, I would have 10 square root 3. So that means 10 times the square root of 3. So that would be right here and right here. So if you have that, if I put those together, what I would have is 20 times the square root of 3. So one diagonal is 20 feet, the other is 20 times the square root of 3 feet. And I'm just going to go ahead and leave it like that. Okay, so now we're looking at page 7, number 9. It says, consider the kite WXYZ. If the measure of angle WZT, so this angle right here is 55 degrees, and angle WXY is equal to 30 degrees, find the measure of angle ZWX. So ZWX, we're trying to find this angle here. And then they also say if WZ is 8, so this side right here, WZ is 8, and WT is 5, find ZT. So there's two things we're trying to find. This angle here and this side length here. So something to keep in mind when you're dealing with this is the diagonals are going to be perpendicular. So one of the things is all these angles are 90-degree angles. So one, they are perpendicular. Another thing to know is that one of the diagonals bisects the non-congruent angles. So these angles are the non-congruent ones to each other. So they get bisected. So if this full thing was 30, that means this one's 15 and this one's 15. So the full thing's 30 like I had originally, but if with this being bisected, this part's 15, this part's 15. So now what we would want to do is, with what I have, I can actually figure out this portion and I can figure out this portion. The reason being is because of the Triangle Sum Theorem. So a triangle, all the angles added together have to equal 180 degrees. So if I have 55 and 90, what I want to do is 90 plus 55. That equals 145. Well, the whole thing has to equal 180, so if I did 180 minus 145, I would get 35. So this angle right here is 35 degrees. So this portion of this angle is 35. Now on the other side, I want to go ahead and do the exact same thing. So what I'm going to do is 90 plus 15. So I would have 105. And now I would do 180 minus 105. And that would get me 75. So this angle right here is 75 degrees. So now to find the full angle like they want us to do, which we're trying to find angle ZWX, the full thing, what I want to do is 75 plus 35, and that'll get me 110 degrees. So this angle right here is 110 degrees. Now, to find the other thing I'm looking for, this angle here, now, as you should have noticed earlier, we had right triangles. So if you have two sides of a right triangle and you're trying to find the last side, you can use Pythagorean theorem. So our a squared plus b squared equals c squared. So a could be the 5 here, so 5 squared plus b squared, because I'm still trying to find it, equals the hypotenuse, the longest side, which is 8, so 8 squared. So now you have 25 plus b squared equals 64. So now what I want to do is subtract 25 to both sides so that we can get b by itself. B squared equals 39. Now I want to get b by itself, and the way that we're going to do that is the way you get rid of a square is through a square root. So square root of 39, and that you can't put that in any simpler and simplified radical form. So I'm just going to go ahead and keep my answer like that. So the length of ZT is the square root of 39. Thank you once again for watching. That's the end of this video. Make sure you like, subscribe, and get those post notifications.